Good evening everyone. Welcome to the previous year's questions of RRB JE regarding to the soil mechanics. Okay, so in this session we are going to discuss about the previous year's questions along with certain other type of questions that relevant to the RRB JE examination CBT part 2. So in the case of the CBT paper 2, the total number of marks are 100 marks. And out of that, one of the major subject is soil mechanics or geotechnical engineering. So in the previous year's pattern, the number of marks, the amount of the marks that obtained from the geotechnical engineering is a minimum of 8 marks, maximum of 12 marks. So you can say an average of 10 marks, right? 8 to 12, average of 10 marks, which is 10% of the total weightage is from the, what I mean? It is not in mute. Students, let me know, is my voice is clear? And audio is clear? A little better, huh? Is my voice clear? Am I audible? Please let me know by commenting. Now still, is my voice clear? Students, please let me know, is my voice clear or not? Please do message in the comment section. Okay? Clear? Yeah. So now I hope my voice and audio both are clear. So let me explain once again. So today we are going to discuss about the previous year's questions and the paper pattern of RRB JE CBT-II. So computer based test paper 2 in RRB JE regarding to the soil mechanics. Here not only I am taking the previous year's questions but also some of the questions which are relevant to the RRB JE level. Now out of the entire marks in the CBT paper 2, out of the 100 marks, one of the most important and highest weighted subject is soil mechanics. So from soil mechanics, we can expect a minimum of 8 marks, maximum of 12 marks, with an average of 10 marks. So 10 marks out of 100, which is a 10%. So you want to get very good rank and you want to score more number of marks in RRB JE CBT paper 2. So you must have to go through the soil mechanics. So now, based on the syllabus, RRB JE syllabus, I have created some of the questions, and let's see those questions one by one. So now still, I think my voice is clear now. Yeah, Srikanth, it's fine, right? Yeah. So now coming to this question. First of all, let's see the questions with respect to the physical properties of the soil. See, for the examination, majority of the questions will be asking for the first few chapters, which is the physical properties, index properties, classification. So most number of questions would be coming from those. So remaining questions will be coming on and off in the remaining chapters. Okay. Now, if the soil sample is having a porosity N value as a 50%, the degree of saturation at 90%, then what is the percentage air voids? They are asking about the percentage air voids. What is the percentage air voids? You see, in the case of the physical properties, there are some basic definitions are there. What are those basic definitions? Void ratio, porosity, degree of saturation, air content, water content, and percentage air voids, right? So they're asking about the percentage air voids. How to find out the percentage air voids? Na is equals to N into AC. We know the porosity, but we need to find out the air content. So what is the relation between the air content and degree of saturation? The degree of saturation SR plus AC is equals to 100. See, porosity means percentage of void in the soil, right? Whereas degree of saturation is the amount of water in the void. Air content is the amount of water in the void. So if a soil has a 90% of saturation, which means voids are 90% filled with water, then how much amount of air is there? Just 10%. So air content is equals to 100 minus 90, which is equals to 10%, which is equals to 10%. So then what is the percentage air voids is porosity, which is 50%, that is 0.5 into 10. So that is going to be 5%. The percentage air voids are just 5%. Okay, so that is how you have to find out this one. Okay, these are nothing but the relations. So if you know the porosity and air content, how to find out the percentage air voids, and the relation between the degree of saturation and air content, SR plus AC is equals to 100%. Now come to the next question. The most commonly used method for the quick determination of the water content at field embankment. So my dear, they are not asking the most commonly used method. Most commonly method used for quick determination. That point is very, very important. Out of all the methods, the most commonly used method is oven drying method only, but it will take very long time. It takes 24 hours to get down the results. And the method that is going to be gives the quick results within 5 to 7 minutes is calcium carbonate method. So whatever the method that gives is calcium carbonate method. Oven drying, sand bath, alcohol, and calcium carbonate method. Quickest method is the calcium carbide, and most widely used and accurate technique is the oven drying method. Next, if void ratio is given as 0.67, water content is 18.8%, that's nothing but water content 18.8%, and specific gravity G value is given as 2.68, the degree of saturation. Mind you, definitely you are going to get a question based upon this model. Without this model, there is no question from the RRB JE. You take it RRB JE, or you take it SSC JE, or you take it any central level examination or state level examination, this concept, the concept is Sevag. So that Sevag, what is the meaning of Sevag, sir? Like I say that SE is equals to WG, or you can write as E into SR is equals to W into G. You know void ratio, you know water content, you know specific gravity, you can find out the degree of saturation, right? So that degree of saturation is equals to water content is 0.188 into this is 2.68 by void ratio is 0.67. So let me know the answer, please. Let me know the answer. I need your answers. Come on. What's the value? What's the answer, please? I need your answers, man. What is the degree of saturation? You calculate and let me know. Calculate and let me know the answer. I'll see how many of you are attending or answering. What's the answer, please? So if you calculate, you will be getting this value as 0.752, which is in terms of percentage 75.2%. So the correct answer over here is option C. Srikanth, it's not D, it is C. Rakshita, very good. Answer is 75%. See the basic equation, man, this is E into SR is equals to W into G, and you substitute over here, you will be get down the answer, 75.2%. Okay. So next question. Water content of a soil sample is the difference of the weight of the given sample at the given temperature, and the weight determined after drying it 24 hours is at a temperature ranging from, what is the temperature that we maintain is more than boiling point. What is the boiling point of water? 100. More than boiling point of water? 105 to 110. You see, all of these options are less than 100. Na? So you have to, when you're doing the oven drying method, the soil should be dried beyond boiling point of water so that water will get evaporate. So correct answer is 105 to 110 degrees. Okay. Next, a soil sample with the specific gravity of solids. So whatever the specific gravity of the solids is nothing but specific gravity 3 and mass specific gravity of 2. Assuming the soil is perfectly dry. Now, you know, for a given soil there are two types of specific gravities. One is true specific gravity, which represents solids, and other one is apparent specific gravity, GM. That represents the state of the soil. So what is the state of the soil here? Dry. So which means the apparent specific gravity in the case of dry is gamma D by gamma W. So this value is given as 2. Now what I am asking you is determine the void ratio. So how to find out this, sir? You know that the relation, one of the functional relation, see the first functional relationship that you need to remember is Sevag. The next one is gamma D is equals to G gamma W by 1 plus C. G gamma W by 1 plus C. You bring this 1 plus C to the other side, we want void ratio, right? You bring that to the other side, then E is equals to G gamma W by gamma D minus 1. And observe carefully, gamma D by gamma W. Gamma D by gamma W is 2. Gamma W by gamma D is a reverse, na? This is nothing but GM by G by GM of dry, right? So E value is equals to G value is 3. This is reverse, 3 by 2 minus 1. 3 by 2 is 1.5 minus 1. So answer is 0.5. The correct answer over here is option D. Very good. Very good, Rajavardhan. Very good, Padma. Rakshita, Shrikant. Good, good, good. Nice. So this is a question which represents the functional relationship. And next. So coming to the, see, those are some of the questions with respect to the physical properties. Now coming to the questions with respect to the Attapag limits. Attapag limits nothing but a liquid limit, plastic limit and shrinkage limit. Okay. So the toughness index is defined as, this is one of the question which was asked n number of times in the case of previous SSC JE, RRB JE and state service examinations also. So what is the toughness index, sir? Toughness index IT is equals to IP by IF. What is IP, sir? Plasticity index, and IF is flow index. So it's a ratio of plasticity index to the flow index. So the correct answer is option B. Next, uniformity quotient of a well-graded soil. Uniformity quotient of a well-graded soil. So you take any soil, to represent the gradation of the soils. We have two coefficients. What is that? One is quotient of uniformity, which is nothing but D60 by D10. And other one is quotient of curvature, D30 square by D10 into D60. So generally the quotient of uniformity and quotient of curvature are going to be explained for the coarse grain soils. And what are the coarse grain soil? Gravel and sand, right? So in the case of the gravel, to make it as a well graded gravel, Cu must be greater than 4, Cc must be 1, 2, 3. In the case of the gravel, to say gravel as well graded, Cu must be greater than 4, Cc must be 1, 2, 3. And in the case of the sand, to make it as a well graded sand, SW, Cu must be greater than 6 and Cc must be 1, 2, 3. Now coming to the question. So the coefficient of uniformity of well graded soil, they did not mention whether the soil is gravel or sand. Now from the options you see, it is less than 2. No way. The minimum value for the well graded, you see, if you want to say gravel, then Cu greater than 4. If you want to say sand, Cu must be greater than 6. So minimum value is, you can see, 4. Now less than 2, greater than 2, now greater than 2, but it may be less than 6 also, right? Greater than 6, yes. Suppose if the value is greater than 6, then obviously it is greater than 4, right? If the value is greater than 6, then obviously it is greater than 4 also. Suppose if I give you Cu value as 7, Cu value 7 matlab Cu greater than 4, Cu greater than 6. It can be well graded gravel, it can be well graded sand. Sir, why not greater than 2, sir? Yeah, greater than 2. Suppose I take 5. Yeah, 5 is greater than 2, which is greater than 4. Gravel will be well graded, but less than 6. Sand will be poorly graded. So I want the well graded soil, which means well graded gravel, well graded sand. Must be, Cu value must be greater than 6. The correct answer is option C. The correct answer is option C. Okay. Now, come to this one. If the plasticity index of a soil mass is 0. So first of all, what is the plasticity index? The plasticity index is nothing but liquid limit minus plastic limit. If I say this is going to be 0, there is no plastic state. No plastic state. So when IP value is equals to 0, no plastic state. So that is nothing but non-plastic soil. Out of this, which is non-plastic soil? Clay is very highly plastic. Clay is silt, moderate plastic. Silt, low plastic, and sand, non-plastic. The correct answer is option C. Sand is a non-plastic soil. Gravel and sand, they are non-plastic soils. Next, identify the consistency limit corresponding to the smallest water content at which a soil is still in the liquid state. If you recollect the consistency chart, when we draw the consistency chart, so the water content is on the x-axis, volume is on the y-axis. You know that at water content 0, the volume is in a dry state only, which is nothing but Vd. When the soil is in dry state, when you add water till full saturation, volume remains same. So whatever the degree of saturation here is 0, till full saturation, the degree of saturation remain same. And whatever the water content at this point is a shrinkage limit. Beyond full saturation, if you add water, the volume will keep on increases. When the volume keep on increases, this is going to be looks like this, right? The state of the soil keep on changes. So this is a semi-solid state, sorry. So here it is a solid state. So that is going to be changes to semi-solid state. So this is the plastic limit, and then soil changes to plastic state. So till it reaches to the liquid limit, then beyond this, this is going to be the liquid state. Now you tell me, so in all the cases degree of saturations are 100%, right? Now what is the minimum water content at which soil still remain as a liquid state? Now when you dry the soil, see, any moisture content more than this one, soil is a liquid state. When you dry the soil, till it reaches to the liquid limit also, soil is in liquid state or not? The minimum water content at which soil still remain as liquid state is liquid limit. So the correct answer option over here is option C. The correct answer is option C. The correct answer is option C. Okay. Next, the liquid limit and the plastic limit of a clay materials is 45% and 25% respectively. So liquid limit is given, plastic limit is also given. Liquid limit is 45%, plastic limit is 25%. what is the activity of the clay material if 20% by weight of particles of size less than 2 micrometers? So they're asking activity if 20% of the soil is less than 2 microns. Arey bhai, whatever the soil finer than 2 micrometers is nothing but clay. So percentage clay is nothing but percentage finer than 2 micrometers. What are the soil? How much amount of the soil is finer than 2 micrometers is 20%. So this is 20%. So now activity A is equals to IP by percentage clay. What is IP? Liquid limit 45 minus plastic limit 25 by 20. 20 by 20. What is activity? It is going to be 1. Sometimes instead of giving you the activity value, they'll ask you the state the nature of the activity. So usually when activity is less than 0.75, we call it as inactive. If the activity is 0.75 to 1.25, we call it as normal. If the activity is greater than 1.25, we call it as active, right? So now you tell me, in the case of this one, activity is 1 which is between 0.75 to 1.25. Instead of options, if they would have given the nature, the answer is normal. The answer is normal. So for the given options, the correct answer is option D. Okay. Next. So black cotton soil. Black cotton soil is not suitable for the foundation because black cotton soil is a highly expensive soil. Okay, fine. But why is not suitable for the foundation is it has very low bearing capacity, man. The bearing capacity of the soil is very less. So usually if there is a black cotton soil mass, you better not to construct a structure on it. If you want to construct a structure, then you must have to provide the raft or mat foundation. And you need to go deeper layer. So the problem with that is construction cost will be less than the foundation cost. You have to spend a lot of cost, lot of amount for the foundation itself. So which is not viable or economical, okay? So black cotton soil are not suitable for foundation because of its low bearing capacity, not swelling and shrinkage. Yes, swelling and shrinkage is there. But first of all, you have to construct the structure. Na? Structure will construct if the soil will be able to take the load, right? Okay. Now, sand particles are made of. You see, sand particles are made of. Now, coelenite, illite, montamonite, these are all the clay minerals. These are all the clay minerals. So, sand is made up of the rock mineral which is nothing but quartz. Sand is made up of rock mineral which is nothing but quartz. So, the correct answer is option D. The correct answer is option D. Next, plasticity chart gives a relation between. See, to classify the fine grain soil, we draw the plasticity chart. If you recollect the plasticity chart goes as on x-axis liquid limit, on y-axis plasticity index. And to classify the fine grain soil, we have a line known as a line, which starts at a liquid limit of 20%. Whatever the soil above the line is a clay, below the line is a silt. And whatever the soil whose liquid limit is less than 35% is low, and 35 to between is intermediate, and more than 15 is high compressible. So above a line clay, less than 35 low compressible clay, and low compressible clay. Mind you, when you represent that name, always the symbol should come from last to first. So reverse order. You speak a name, symbol should be reverse order. Low L, compressible clay C. Now reverse order C L. Low compressible clay, intermediate compressible clay, which is nothing but Ci. High compressible clay, which is nothing but Ch. So below Ml, Mi, Mh. Apart from that, there is a one small shaded portion. This is located between the plasticity index values 4 and 7. This portion is ClMl. I just want you to go with the graph. So what is the one is a soil lies above a line is clay, below a line is the silt. and less than 35 is low compressible, 35 to 50 is intermediate, more than 50 is high. Sometimes they will give you the plasticity chart and they'll mention you this is X. So they'll give you the plasticity chart. From the plasticity chart shown, the X represent what? And they'll give you the options, option A, option B, option C, option D. And mind you, these are inorganic clay, okay? These are inorganic clay, not organic, these are inorganic clays. So now, come on, the question is not about this, but you see, plasticity charts gives a relation between what? Plastic limit and plastic index and liquid limit, IP and liquid limit. The correct answer is option C. Okay, now according to Indian standard classification, the soil is classified into how many groups, man? 18 groups. 18 groups. So in the case of the soil, we have coarse grain, we have fine grain, and we have pure organic soil. And in the case of the coarse grain, again there is a gravel, there is a sand. So in the case of the gravel, 4 groups. It can be well graded gravel, poorly gravel, silty gravel, clayey gravel. Similarly sand, well graded sand, poorly sand, silty sand, clayey sand. Do remember when I say a name, symbol has to come from last to first. Similarly in the case of the fine grain, so for the silt, just now I mentioned you, low compressible silt, intermediate compressible silt, high compressible silt. In the case of the clay, low compressible clay, intermediate compressible clay, high compressible clay. And in the case of organic clay or silt, mind you, this organic clay or silt is nothing but organic soil mixed with inorganic clay. So now for this also, OL, OI, OH, which means low compressible organic soil. So now, so how many groups are there here? In the case of the coarse grain, total gravel 4, sand 4, total 8. In the case of the fine grain, each soil has 3 groups, silt 3, clay 3, organic 3. So this is nothing but 9, and pure, this is nothing but 1. Total 8 plus 9 plus 1, 18 groups are there. So this is how we classify the soil, right? And how to fix GW, GP and all, you know, CU greater than CC, CU and CC, right? So the total number of groups for a given chart is nothing but 18 groups. The correct answer is option B. Very good. Now, which of the following statements about gap grading of the aggregates is true? Gap graded or skip graded? We can also call it as a gap grading or a skip grading. Okay. So in gap grading, one or more intermediate fraction of particles are absent. Yes. You draw the graph for the gap graded. In the case of the graph where log D and y-axis is percentage finer, if you draw the graph is going to be the graph looks like continuous and then constant and then continuous. So if you observe carefully, at this point, this is a horizontal line. In this horizontal line, the particles between these two are missing. Some particles are missing because before that it is continuous, after that is continuous. The horizontal flat line represents different particles have same percentage finer. That particles are missing. So in gap graded, certain fraction of particles are missing. The correct one is, first one itself is a true. Remaining you check. Gap graded, the grading curve is smooth. No. You see, there is a gap. There is a break in the gap. This is nothing but break. It's not a smooth curve. There is a break. In gap grading, all particles are of uniform size. Nope. Gap graded has wide distribution of all grain size particles. No. If particles have almost uniform size, we call it as a uniformly graded soil. And wide distribution, we call it as a well graded soil. So the correct answer is option A. Option A. Okay. Next, between the seepage velocity and discharge velocity in a soil, between the seepage velocity, now there comes the Darcy's law, seepage velocity and discharge velocity. Discharge velocity was given by the Darcy. So which of the following is going to be true? So first one, the former is always higher, the latter is always higher, anyone may be higher. Former is Vs, latter is V. You know, always always, generally, the seepage velocity is the discharge velocity by porosity, where n is nothing but porosity. The range of the porosity is 0 less than n less than 1. So n will be always less than 1. Denominator always less than means Vs will be definitely greater than V. So always seepage velocity, the former value is greater than the later value from the given. So the former is always higher. Seepage velocity is always higher. Okay. Next. A loose uniform sand with a rounded grains has an effective grain size of 0.05 centimeters. So effective grain size is given, which is nothing but 0.05 centimeters. Then coefficient of permeability of the sand. So what is the relation between the coefficient of permeability and effective size d10 is K is equals to 100 into d10 square, where K should be in terms of centimeters per second, d10 should be in terms of centimeters. Now please substitute. So 100 into d10 0.05 whole square. So which is nothing but 100 into 5 square is 25. Let me take it as common. 0.05 10 power minus 2 power square 10 to the power of minus 4. So the answer will be like you see 10 square will be gone. So the answer will be like 0.25 centimeters per second. The correct answer is option A. The correct answer is option A. So this is the relation between the coefficient of permeability and effective size, where K is equals to 100 into d10 square. Okay. Now come on, solve this question. Solve this question, everybody. I need you to solve this and give me the answer. Okay, so if the void ratio and discharge velocity for a given soil, so they have given the void ratio, and discharge velocity. What is meant by discharge velocity? Void ratio is E, discharge velocity is V, 16 to the power of minus 7 respectively. What is the value of the seepage velocity? Just now we got the relation, man. So Vs is equals to V by N, but N is porosity. They have given void ratio. How to find out porosity? The relation between the void ratio and porosity is N is equals to E by 1 plus C, which is 0.5 by 1 plus 0.5. 0.5 by 1.5, that's going to be 1 by 3. You keep it like this. Then Vs is equals to V, 16 to 10 to the power of minus 7 by 1 by 3. So answer is 18 into 10 to the power of minus 7 centimeters or meters per second. So 18 into 10 to the power of minus 7. The correct answer is option D. Correct answer is option D. So you see, in the case of RRB JE, the level of questions would be like this only. They will not go for too deep, man. They will not give you too much amount of calculations. They will try to go with the conceptual questions and surface level numericals. Okay. Now, which of the following is a method used in a field to determine the permeability of the soil? So, which is used in the field? What is the field method? Odometer method or consolidation method, that is for consolidation, not for permeability directly. So, that is a lab test. Falling head permeability test, lab test. Constant head permeability test, lab test. See, odometer test is to determine permeability only. But, consolidation and permeability, but those are the field tests, lab tests. What we are asking is a field. So, pumping out of the well method, that is going to be the field method. Option D. Next. Due to rise in the water table, the effective stress in a soil. Come on, everybody. So now there comes the effective stress. If this is the ground level, if this is the water table. Suppose if this water table rises to this point, what happens to the effective stress? What is effective stress? Stress transferred from one grain to another grain, which depends upon the contact between the particles or not. Now if the water table is going to be rises, then the contact between the particles will decreases. If water table rises, the contact between the particles will decrease, then effective stress will decrease. So whenever the water level rises, the effective stress is going to be decreases. the effective stress in the soil will decrease. If the water table falls, the effective stress in the soil will increase. Correct answer is option B. Next, you see this question. Which of the following statement are true about the quicksand? What is the statement? Does quicksand is a type of sand or a condition? Condition. It is only a condition but not a type of sand. Yes, that's true. It's a condition. It's not a name of the sand. It is a condition and type of sand too. No, this is not true. So now, quicksand condition reaches when the critical hydraulic gradient is approximately equals to unity. Yes. So whatever the critical hydraulic gradient, generally the critical hydraulic gradient is nothing but 1. Whenever the gradient reaches to 1, that means that reaches the critical state. So quicksand condition will occur. Yes. Quicksand condition occurs more commonly in coarse grain sands. No. Quicksand condition occurs in the case of low permeable cohesionless soil. Low permeable cohesionless soil means fine sands and silts. So this occurs more in fine sands and silts. So statement number 4 is incorrect. So out of the 4 statements, what are the statements correct are? 1 and 3. So 2 and 3 are correct? No. Statement 2, 3, 4 are correct? No. So now both the statements 1 and 3 are true. The correct answer is option C. The correct answer is option C. Okay? The correct answer is option C. Next, bulking of a sand. Where do you see bulking of sand? Bulking of a sand we do observe in the case of the dense sands, not in the loose sands. And the two fine sand. And the two fines are not in the coarse sand. Okay. So bulking, what is meant by bulking, sir? Sir, bulking means actually at low moisture content, in the case of the fine sand, void space is very less. Capillarity will be more. So when you add water, instead of filling in the void, due to capillarity, it will form as a capillary film. So that particles will move away. Due to the capillary film, on the top of the particles, sand particles, so water will form as a capillary film. This capillary film made the particles to move away. So that volume of soil will increase, known as bulking. So bulking of sand is seen more in the case of the fine sand. It happens in the sand only, but smaller the size, more the bulking. Fine, medium, coarse. Which one has more bulking is fine sand. So option D. Next, the total and effective stress at a depth of 5 meters below the top level of water in a pond. Look, this is the bed level and this is the water level, pond. What they are asking is below the 5 meters of the top level of water. So they are asking at a depth of 5 meters. This entire is water. They are asking about total stress and they are asking about the total stress and effective stress. Sorry. Yeah, total stress and effective stress. So how to find out the total stress, sir? Sir, total stress is nothing but you just keep your palm, whatever the unit weight that is going to be there, multiply with the depth, gamma W into 5. So now, if you look into over here, so what is the total stress, sir? Total stress is nothing but weight of water. This is nothing but water only, right? Water into 5. But what is gamma W? Gamma W is nothing but 1000 kg per meter cube. They're asking in terms of a centimeter square, right? So now, this is going to be 1000 kg per meter cube into 5. 5 meters, which is nothing but 5000 kg per meter square. But I want to convert that into centimeter. So 1 meter square is nothing but 10 to the power of centimeter square or not? 1 meter square, 10 to the power of 4 centimeter square. Send the 10 to the power of 4 to the numerator, then it becomes 0.5 kg per centimeter square. That's a total stress. But what about effective stress, man? Effective stress is a stress transfer between the grain to grain, solid to solid. If there are no solid, I am talking about the section in the water. So when there is no solid, no effective stress. So simply I will write no solid, no effective stress. Or else you can do one more way. How to find out effective stress is total stress minus pore water pressure. What is the pore water pressure? You insert the piezometer, water level will rise to the same height. The pressure height is 5 meters. So then also gamma W into HP, then also that value is equals to 0.5 kg per centimeter square. Then the effective stress is nothing but total stress minus pore water pressure, which is going to be 0. So or else simply, if they ask you effective stress in water, that effective stress is, the correct answer is option B. Okay. So yeah, the correct answer is option B. Next, the specific gravity of a soil is represented by G and void ratio is given as E. What is the critical hydraulic gradient? So the critical hydraulic gradient IC is equals to G minus 1 by 1 plus C or G minus 1 into 1 minus N. Whenever the factor of safety, what is the factor of safety is IC by I. Whenever the hydraulic gradient is greater than or equals to IC, then the piping failure will happen, not equals to. When I greater than IC, then piping failure will happen. So the maximum amount of the gradient is, for no failure, is a critical hydraulic gradient, which is G minus 1 by 1 plus C, option A. Next, a sand deposit has a porosity 1 by 3, specific gravity 2.5, critical hydraulic gradient to cause sand boiling in the stratum. Just now I said, what is the critical hydraulic gradient? This time they have given in terms of porosity. So G minus 1 into 1 minus N, 2.5 minus 1 into 1 minus 1 by 3. So 1 minus 1 by 3, 2.5 minus 1 is 1.5 into 1 minus 1 by 3, which is going to be 2 by 3. Like this is nothing but 0.5. The answer is 1. So the critical hydraulic gradient is 1. Usually the critical hydraulic gradient value is almost equals to 1. Whenever the IC is almost equals to 1, then that is going to be cause a quicksand condition. Okay, so the answer is option C. Hope you understood. The answer is option C. Is my voice clear? Yeah. Next, which of the following statements are correct? Isochrones are the curves of equal pore pressure distribution. No. Isochrone, so during consolidation, isochrone represents the variation of the excess pore water pressure with respect to depth. At the top, excess pore water pressure 0. At the bottom, excess pore water pressure 0. At the middle, excess pore water also changes with the time. The correct answer is 2 and 3 only. The correct answer is option B. The correct answer is option B. Next, which of the following statement is true? On an absolutely rigid foundation base, the pressure will more at the edges on the foundation. Look, on an absolute rigid foundation, the base pressure will be more at the edges of the foundation. First of all, if I say rigid foundation, in the case of the rigid foundation, settlement is uniform, contact pressure is non-uniform, and that non-uniformity depends upon the type of the soil. So all the questions are with respect to the rigid foundation only, right? So if I take a rigid foundation, in the case of the rigid foundation, settlement is going to be uniform. So settlement is going to be happen uniform. But contact pressure depends upon the type of the soil. If the soil is clay, in the case of the soil, it edges strength more, contact pressure is more. This is how the contact pressure distribution looks like. In the case of sand, it edges strength less, contact pressure is less. So this is how the pressure distribution looks like. So in case of rigid footing, settlement is uniform, contact pressure is non-uniform. But you see, on an absolute rigid footing base, the pressure will be more at edges of the foundation. Pressure is more at edges for what soil? Clay. But did they mention the type of soil? No. On absolute rigid foundation, the pressure will be uniform. Definitely it is not going to be uniform. On absolute rigid foundation, base pressure will not be uniform. The answer is not uniform because they did not mention anything regarding to the type of the soil. So it is not going to be uniform. The correct answer is option C. In case of the clay, it is more at the edges. In the case of the sand, it is less at the edges. So pressure will be 0 at the center of the foundation. No, it's not going to be happen. So the correct answer is pressure will not be uniform. If they would have mentioned the type of soil, clay or sand, then you can say more or less. Okay? So the correct answer is option C. Next, the consolidation time for a soil. So whatever the consolidation time for the soil, time of consolidation increases with increase in compressibility. Yes, the more the compressibility of the soil, more water goes out, more time take. Decreases with increasing permeability. Yes, more the permeability of the soil, water can go out very easily. If the permeability of soil is more, water will go out very easily. When water goes out very easily, then permeability, then time will be less. Is independent on the stress change? Yes. See, consolidation time does not depend upon the stress change. So the correct answer is option D, all of the above. The correct answer is option D, all of the above. Next, the relation between the coefficient of consolidation and time factor. So that is nothing but TV is equals to CV into T by D square. You send it to this one, CV is equals to TV into D square by T. TV into D square by T. So where the correct answer is option A, CV is equals to TV into D square by T. Next, in a consolidation test, when the load is changed from 50 to 100 kg per meter square. So 50 to delta sigma dash is nothing but 50 to 100 kg per meter square, 100 minus 50, that is going to be 50 kilopascals. The void ratio changes from 0.8 to 6. The change in void ratio is 0.8 minus 0.6, which is nothing but 0.2. The coefficient of compressibility will be, look, coefficient of compressibility is nothing but AV. That slope, change in void ratio by change in stress, which is 0.2 by 50. The correct answer would be, tell me, what's the correct answer? The correct answer would be 0.004 meter square per kilonewton. Meter square per kilonewton, right? The correct answer is option D, 0.004. The correct answer is option D. Okay. So I hope you are able to recollect all the concepts which we are discussing. So is this session is useful? If the session is useful and if the session is allowing you to recollect all those data, so say yes and give your feedback too. Come on. Is the session is useful? So far we have covered a lot of topics already. Index properties covered, physical properties covered, permeability, effective stress. Okay. So we discussed about the seepage. We are discussing about the consolidation too. So is this session is helpful for you? Let us know. Yep. Okay, so now let's see this question. A saturated soil, again one more question from the consolidation. A saturated soil has a compression index. What is the compression index? 0.28. Void ratio at a stress of 12 kN per meter square is 2.05 and its permeability is given K value 35 into the power of minus 3. This is not 3. This is 10 to the power of 10 to the power of minus 3. What is the change in void ratio if the stress is increases to 21.6? What is the change in void ratio if the stress is increases to 21.6? Man, they have given the compression index. The compression index is nothing but change in void ratio by log base 10 sigma dash by sigma naught dash. Okay, so CC value is given as 0.28. Change in void ratio, what is initial? 2.05. Final E minus initial 2.05 by log base 10. What is the final stress? 21.6 by initial stress how much? 12. Okay, you see here 21.6 by 12. They have given log 10 1.8, right? 21.6 by 12, that's nothing but log 1.8. So this is E minus 2.05 by log base 10 1.8. And that 1.8 value can be taken as 0.255 or not. Send it to the other side. So E minus 2.05 is equals to 0.255 into 0.28. So tell me the void ratio. And they're asking change directly. So you don't need to find out the void ratio also. They're asking the change. So they're not asking what is the final void ratio. They're asking the change. So change is nothing but delta E. Simply find out the delta E. What is the delta E value now? So this is going to be 0.0714. So the correct answer is option A. Sound is not audible. Please increase the sound. Is my voice is clear? Okay. So now what is the quotient of consolidation units? The quotient of consolidation is CV, where CV is equals to K by MV into gamma W. The units will be either meter square per second or centimeter square per second. So the correct answer is option B. Rotate. Now pick up the incorrect statement. This is about the compaction. Pick up the incorrect statement from the following. Well-graded coarse-grained soil can be compacted to a very high density as compared to the fine-graded soil. Yes, well-graded soil, wide representation of soil are there. You compact, you will get more density because compaction will be more in well-graded soil. Yes, that's true. The dry density decreases after attaining optimum moisture content. Yes, you know the compaction curve till it reaches the dry density maximum. So this is nothing but the optimum. Beyond optimum, the dry density is going to be decreases. That's also true. Now by compacting at high enough water content, we can produce soil at 100% saturation. What is the meaning of 100% saturation? Air content is equals to 0. It is not going to be possible. No matter how much compaction you do, you cannot remove 100% of air. Because in compaction we apply the load, we lift. We apply, we lift. During that process, certain amount of air will still present in the void. So you will never see 100% expulsion of air. So the correct answer is option C. Okay, so incorrect statement. Next, optimum moisture content is obtained from what test? Triaxial test, standard Proctor test, standard modified IS lightweight test and IS heavyweight test. So the correct answer is option B. Next, which of the following type of roller is most suitable for proof rolling, subgrades and for finishing operations? So whatever the subgrades, in the case of the roads and finishing operations, most common one is smooth wheel roller. Smooth wheel roller. That is very, very important. For the finishing operations, what we use is a smooth wheel roller. Okay, so the correct answer is option C. Now, which of the following is not correct about the effects of the compaction of the soil? So which of the following is not correct about the effects of the compaction of the soil? Which of the following is not correct? Compaction increases shear and bearing strength of the soil. Yes, you compact, then strength of the soil and bearing capacity increases. That's correct only. Compaction increases the permeability of the soil. No, compaction decreases the permeability of the soil. Compaction decreases the permeability of the soil. So incorrect statement is this one. Compaction increases the frictional characteristics. More compaction, more friction. Compaction decreases the tendency for settlement. Yes, if soil got compacted, then particles will come closer, settlement will be less. So the incorrect statement over here is compaction increases the permeability. No, it will decrease the permeability. Next, the coefficient of passive earth pressure for cohesionless granular soil. For active earth pressure, Ka is 1 minus sin phi by 1 plus sin phi. That is active. And for passive, reverse 1 by Ka, which is nothing but 1 plus sin phi by 1 minus sin phi. So 1 plus sin phi by 1 minus sin phi, the correct answer is option A. And if they ask you at rest, K naught, that's going to be 1 minus sin phi. Option A is the correct answer. The correct answer is option A. Yeah. Next, an excavation is to be made in a saturated soft clay, phi value 0, with the vertical sides. What will be the maximum unsupported depth of vertical cut given that cohesion intercept is 30 and the unit weight of the clay is, this is C and this is gamma. You know the maximum depth up to which you can excavate without support is critical height. That critical height is 2 times of ZC, which is nothing but 4C by gamma root Ka. When phi value is equals to 0 degrees, Ka value is equals to 1 minus sin 0 by 1 plus sin 0. Then critical height is equals to 4 into C value 30 by gamma value as 15. So 15 to the answer will be 8 meters. The critical height will be 8 meters. What is the correct answer? The correct answer, critical height is 8 meters. So in the case of the earth pressure theories, this is one of the topic. They can ask you the critical depth or they can ask you the critical height. They will ask you the coefficients Ka, Kp and K0. For certain soil, the angle of internal friction phi value is given as 30 degrees. What is the quotient of active and passive earth pressure? So it's direct question I have already mentioned in the notes as, in classes and all. So phi value 30 degrees, Ka 1 minus sine 30 by 1 plus sine 30. Sine 30 is 0.5. So this is going to be 0.5 by 1.5, 1 by 3. And you know Kp is the reverse of Ka, 1 by Ka. So the answer will be 3. So now the correct answer is 1 by 3 is nothing but 0.33 and 3. Active is 0.33 and passive is nothing but 3. Now plate load test is used to determine what is the purpose of the plate load test. The purpose of the plate load test is to determine the bearing capacity of the soil and to find out allowable settlement of the soil. Ultimate bearing capacity and allowable settlement, both. Bearing capacity and settlement, you need to find out both A and B. Plate load test is a field test to determine those. Now a 300 mm square bearing plate, so width of the plate is 300 mm which is nothing but 0.3 mm, settles by 15 mm in a plate load test on a cohesive soil. Cohesive soil is nothing but what? Clay. When the intensity of loading is 0.2. The settlement of the prototype of a shallow footing 1 meter square footing. So width of the foundation is nothing but 1 meter. What is the settlement under the footing? That's the question. You know that in the case of the clay, settlement is directly proportional to width. So SF by SP is equals to BF by BP directly. So SF under the plate it is 15 is equals to width 1 by 0.3. So what is the SF now? So 15 by 0.3. What is this value? The value is going to be 50. You solve, that's going to be 50 mm. So this is about in the case of the plate load test. You know, under the plate the settlement is less, but under the footing width will be more, settlement will be more. You have to do the correction like this. SF by SP is equals to BF by BP. The correct answer is 50 mm. Now the depth of the foundation is usually calculated by using the Rankine's theory. Actually, as per Rankine's theory, so the minimum depth of the foundation is equals to Q by gamma into Ka square. The Rankine's theory is unable to explain the bearing capacity at ground surface. That's why instead of using this for the bearing capacity formula, we use it to determine the minimum depth. You have seen the same formula in RCC also. The two criteria for the determination of the allowable bearing capacity. See, allowable bearing capacity. First of all, you know when a soil is going to be failed, first it undergoes normal stress, which means it undergoes settlement. Then shearing, which means shear failure. So when I apply the load, soil should not undergo excessive settlement and soil should not undergo shear failure. So I have to design that no excessive settlement and no shearing failure. Tension failure and compression failure. Tension failure and settlement. Arey bhai, first of all, whatever the load I am applying is compression, man. Why the tension will come? Tension, no tension. Bond failure and shear failure, no bond. What is the failure? Shear failure and settlement. So I have to see that there should be no excessive settlement, there should be no shear failure. The correct answer is option D. That's a design criteria. Next, in a rigid footing on a cohesive soil, already we have represented. The contact pressure distribution, I already mentioned you, if you go back and if you have a check with respect to this one. Yeah, so rigid footing on clay. Rigid footing means settlement is uniform. In the case of the clay, at edges the strength is more, which means contact pressure is more at the edges in the case of the clay. So now that one we are going to use is here. So rigid footing, cohesive soil, the contact pressure is non-uniform. Yes, more at edges, less at center, with the maximum at the ends and the minimum at the center. Yes, non-uniform with the maximum at edge and minimum at the center. That is the answer A, option A, correct answer. Next, the grouping of a pile will not reduce the load carrying capacity in the case of the grouping of a pile. So pile grouping will not reduce the load carrying capacity. See, when you do the pile grouping, it will not reduce the load carrying capacity in the case of the end bearing piles. Why, sir? Sir, in the case of the end bearing pile, if there is end bearing pile, the pressure ball will be at the bottom. Whereas in the case of the friction pile, the pressure ball will be formed on the sides. So, in the case of the end bearing and in the case of the friction pile, when you do grouping, grouping means piles are going to be next to next. In the case of the grouping, the more pressure ball will be getting overlap in the friction pile. Whereas in the case of the end bearing at bottom, it will not get much of the overlapping. So, which one will not impact or affect more is end bearing piles. Now, a friction pile of a diameter, now they have given clearly the friction pile of a diameter, D value is 0.5, is embedded into 15 meters length, homogeneous consolidated deposit. If the adhesion factor alpha value is given as 0.7 and adhesion between the clay and pile shaft, which is nothing but cohesion, is 4 ton per meter square, what is the safe load with respect to the factor of safety as a 3? Safe load is nothing but ultimate load by factor of safety. Mind you, as given is a friction pile, in the case of the friction pile, whatever the ultimate load is due to the frictional resistance along the length, right? So given QU is equals to QS. How to find out QS is nothing but small qs into AS, where small qs is nothing but the frictional resistance or skin friction resistance. So that is nothing but alpha into average cohesion into what is AS, sir? Surface area of the pile. What is surface area? So you take this as a pile. There is a pile. So this is nothing but diameter. So perimeter is pi d. Surface area is a pi d into L. So pi into d into L. So alpha is given 0.7, C is given 4 into pi into d value is given 0.5 into L is 15. So let me know the ultimate load carrying capacity. Let me know the ultimate bearing capacity. 0.7 into 4 into pi into 0.5 into 15. So this is going to be 65.97. But they are not asking ultimate, they are asking about the safe. So safe is nothing but 65.97 by 3. Approximately, let's say 22, right? Approximately this is going to be 22. 65.97, let's take it as 66. 66 by 3, approximately this is going to be 22. So that's about a question from the pile foundations. We solve the question from the bearing capacity. There is about the foundations, bearing capacity, shallow foundation and pile foundation. So now, which of the following type of foundation is best suited in the case of the expansive type of soil? Expansive, not expensive. High swelling and shrinkage, we go for under-rimmed foundation. So under-rimmed piles or bulbed piles, where you can see the pile will be having a bulb portion. So it will prevent the swelling and it will prevent the shrinkage. The correct answer is under-rimmed pile. Now, which of the following statement is /RR correct? Which of the following is /RR correct? The proportionating of footing is more often governed by its bearing capacity. The proportionating of a footing. So when you are going to fix the dimensions of the footing, it is more often governed by its bearing capacity. Yes, because majority of the soils fails by shear rather than the settlement. So the proportionating while fixing the sizes of the footing, that depends upon the bearing capacity of the soil. A, true. And friction piles are also known as floating piles. The other name for the end bearing pile is point bearing pile and friction pile is floating pile. Both A and B are correct. The correct answer is option B. So with this we have covered the questions with respect to the physical properties, with respect to the index properties, with respect to the permeability, seepage, consolidation, compaction, earth pressure theories and foundations also. So I hope in the brief session of this one hour, so we have gone through the each and every concept and whatever the level of question settlement that can be obtained. So I wish you all the best for the for the upcoming examination at the end of this April. Okay, so all the best. And if you have any doubts, you can drop your doubts in the message and I would be very happy to answer your questions. Okay. So if you have any doubts, you can drop an email to the official website of ACE Engineering Academy, or else you can mail to this mail ID also, which is pawan.acefaculty@gmail.com. So this is my mail ID. You can send your doubts, you can send your questions to this mail ID. I'll reply to you that. Okay. So thank you very much. All the best to you.